Let's move on to the next page. Now, the following graph shows a moving car. Always pick up this habit. Circle, speed. This is a speed time graph. And before you attempt the questions, let's dissect the graph first. Now, let's analyze this graph. If this is a speed time graph, the car is moving at a constant speed of write this down, at constant speed of 30 meters per second, because it's a speed time graph. Now, when the graph is moving upwards in this way, the car is accelerating, constant acceleration, because this is a speed time graph. The speed is increasing constantly, constant acceleration for a line, straight line like that for the speed time graph. So question, how long did the car move at zero acceleration? At zero acceleration means constant speed. When the speed is constant, there's no acceleration, it's not increasing speed. Therefore, asking, how long did it take for the car to move at a constant speed? From 0 to 5 seconds. So answer, 5 seconds. Wherever I've written on the questions, please write it down for your own reference. Next, what is the highest speed reached by the car? Underline highest speed. Now, highest speed reached by the car, looking at this graph, is it 30? No, it increases its speed all the way to 70. So the highest speed reached by the car is 70 meters per second. What is the average speed of the car when it was accelerating? What is the average speed of the car when it's accelerating? Now, to find the average speed, we need to find the total distance divided by the total time. The total distance divided by total time. How do we find total distance? Total distance, remember we have learned, is actually the area under the graph. For this case, how do we find the area under the graph? This is a trapezium. Okay, we can either use the formula of trapezium to find the area under this graph, or what you can do is total distance equals to half times base times height, which is the area of the triangle, plus length times breadth, which is the area of this rectangle. And you add them together. Half times base, 10 minus 5 is 5, times the height from here to here is 70 minus 30, plus the length here is 5, times the height of the rectangle is 30. And the answer is 100 plus 150, 250 meters. Now I don't have space, so I'm going to move down here. So total distance is 250 meters. And what's the average speed when the car is accelerating? So average speed will be total distance divided by, what is the total time taken when the car is accelerating? 5 to 10 seconds is actually 5-second difference. So answer is 50 meters per second. That's my final answer for question C. Find the acceleration of the car. What is the formula for acceleration? Final speed minus initial speed over time taken. What is the final speed? Final speed over here, 70. Initial speed, it started here at 30. Total time taken, 5. So 40 divided by 5, 8 meter per second squared. Don't forget your unit, and that's my final answer for acceleration. Okay, let us continue. A car accelerates uniformly from 10 meter to 80 meter per second in 5 seconds. What is the acceleration of the car? Equals to final minus u over t. Accelerates from 10, this is my u, to 18, this is my v. So final 18 minus 10 in 5 seconds. Answer would be 18 minus 10 divided by 5, 1.6 meter per second. Okay, let's take a look at this question. Which of the following best describes the distance time graph shown? Again, as long as you see this kind of graph, circle the y-axis, okay, to remind yourself this is a distance time graph. So for distance time graph, is this an object travel at constant acceleration, object travel at constant speed, object travel at constant velocity, or the object is stationary? Now, distance is increasing like this. That shows that the object is moving and is traveling at constant speed because this is a distant time graph. So its answer is B. Which of the following describes the distant time graph? Again, circle. This is a distant time graph. 1 second later, it is at 2 meter. 2 seconds later, it is still at 2 meter. 3 seconds later, it is still at 2 meter. So, answer is object travels at constant velocity of 2 meter per second? No, because this is a speed time graph. An object travels at constant acceleration? No. An object travels at a distance of 20 meter? No. And an object is not moving. Answer is D. A jet fighter is cruising at a constant speed of 60 km per hour. What is the distance traveled in 0.5 hours? Give your answer in meters. Speed equals to distance over time. Now, take a look at this carefully. This is in kilometer per hour, this is in hour. So we can use the formula without changing the units first. Speed is 600, distance over 0.5. Distance will be 600 times 0.5 equals to 300 kilometer. Please take note, it's kilometer because the unit here is kilometer per hour. But I want the answers in meter. So what do? Kilometer to meter, you multiply because kilometer is bigger. How much do you multiply? By 1,000. Answer 300,000 meter. That's my final answer. Write down your units clearly. Let's move on to the next page. The average speed of a mountain deer is 50 meters per second. How long does it take for the deer to run 300 meters? Average speed equals to total distance divided by total time. equals total distance 300. Total time is what you want to know. Speed 15. Answer, you cross multiply 300 divide by 15 when you want to get your t. 20. What is the time? Meter per second. The unit for time is second for this case. Let's take a look at this question. The distance time graph of a motorcycle is shown below. Circle distance time graph. During the time interval, did the motorcycle travel the fastest? Now, let's interpret and analyze the questions. Here, this is a distance time graph. Therefore, when it has a horizontal line, this is not moving. Motorcycle not moving. Over here is a straight line going upwards. The motorcycle is traveling at a constant speed. Is increasing. The distance is increasing. This is also in constant speed because the speed is increasing. But the question is, which one traveled the fastest? Is it this or this? Now, you can either calculate the total distance divided by total time, or you see the difference. Here, 5 to 9 seconds is 6, 7, 8, 9, 4 seconds. Within 4 seconds, it has increased 1 meter. Over here, 9, 10, 11, 12. Within 3 seconds, it has increased 6 meters difference. 3, 4, 5, 6, 7, 8, 9. This is 6 meter difference. Here is merely 1 meter difference. So which one do you think traveled the fastest? At which time interval? It's here. This one, 9 to 12 seconds. To explain, you can say the curve is steeper. Here, the line is steeper. With a steeper line, meaning the increase of the differences is greater, therefore, it travels the fastest. Within 3 seconds, there's a difference in 6 meters, whereas this difference in 4 seconds, it has only a change in 1 meter. What is the speed of the motorcycle? It says, check your answer to A by calculating B to D. Let's find the speed of the motorcycle for the first 5 seconds. Speed equals to distance. Divide by time. Now for the first 5 seconds, the distance traveled. The change in the distance Now I repeat myself. For a speed time graph, for a distance time graph, to find the speed, you can also find the gradient of the graph. Remember, to find the gradient of the graph will give you the speed. Now, how do you find the gradient of the graph? Rise over run. But the rise for this line, there's no rise, it's a horizontal line. So it's 0. Divide by the run, it is 5. Answer would be 0 meters per second. For 5 to 9, speed is equals to the gradient of the graph. The gradient here, rise will be 3 minus 2 and run will be 9 minus 5. So I'm going to write it here. Rise over run. The rise is 3 minus 2. The run is 9 minus 5. Answer 1 divided by 4, which is 0.25 meter per second. How about this? Again, speed can also be calculated to find the gradient, equals to rise over run. Now for this rise, it's from 9 to 3. From 3 to 9, the difference. And the run would be 12 minus 9. So 9 minus 3 over 12 minus 9. What's the answer? 2 meter per second. So, which one has the greater speed? So we are correct. From here to here has a greater speed. The fastest. Now, for this, average speed equals to total distance divided by total time. The total distance here is 9 meter. It has traveled a total distance of 9 meter. Divided by total time taken is 12. So answer would be 9 divided by 12. – 0.75 meter per second. A body is accelerated uniformly from rest. In the first 8 seconds of its motion, it travels at 20 meters. Calculate the average speed. Average speed is equals to total distance divided by total time taken, which is 8 seconds. 20 divided by 8, 2.5 meters per second. And the acceleration, if the speed at the end is 5, so at the end is 5, this is v. So initially accelerated uniform from rest, you see the word from rest, initial is 0. So acceleration v minus u over time. My v is 5, initial is 0, the time taken is 8. Answer would be 0.63. 3 significant figure. Okay, make sure you write 3 significant figure. A car accelerates at 0 meter per second squared from an initial speed of 2 for 10 seconds. What is the speed at the end of 10 seconds? 0 meter per second squared is not accelerating. Actually, it's a constant speed. You can write it in this way. When acceleration is 0, means that the speed is constant. Thus, the speed at the end, thus, final speed is also 2 meters per second. To prove to you, you can do the calculation. 0, final, minus 2. Time is 10. 10 times 0 is 0. Equals to v minus 2. So v is 2 meters per second. As I say. Next page. A car accelerates at the rate of 5 meters per second squared from rest for 15 seconds. From rest, this is u equals to 0. What is the speed at the end? What is the speed at the end? What is my v? v minus u, 5 v minus 0 time v equals to cross multiply 15 times 5, 75 meter per second. A car accelerates at the rate of 7 meter per second squared from 2 meter per second for 12 seconds. What is the speed at the end? Acceleration v minus u over t. Acceleration is 7. Final speed from 2 at the end. This is my unknown. From 2. So this is my u. Time taken 12. Cross multiply. 7 times 12 equals to v minus 2. 84 plus 2 give you final. Final speed is 86 meters per second. A car accelerates from 3 to 11. What is the acceleration in 4 seconds? From, this is u, to v minus u over t. Always write down the formula to internalize the formula. 11 minus 3 divided by 4. Answer 11 minus 3 divided by 4. Answer is 2. Meter per second. Make sure your unit is in meter per second. A car decelerates from 14 to rest. What is the time taken? You can use back the same formula, but take note. Deceleration is actually a negative of acceleration. Make sure you put down negative here. Final is 0 to rest. So the final is 0. Initial is 14. Time taken is what you need to find. Cross multiply. This becomes minus t. This becomes minus 14. Drop the negative sign. T is 14 seconds. Next, the diagram shows a velocity time graph. Take note, v time graph along a straight road over a period of 10 seconds. Calculate the acceleration of the car between A and B. Between A and B, acceleration gives you total distance divided by total time. So first of all, we find the total distance. The total distance is the area, half times base times the height, which is 12 times 4 times 15, 30 meter. Acceleration will be total distance divided by total time taken. From here to here is 4 seconds. (7.5 meter per second squared). So it's in meter per second squared.